Alright, hello, welcome back to the channel. Sorry it's been a while, I've been a little busy, but today we're going to start a new series. We're going to look into Rust. So what is Rust? Rust is a low-level, systems-level programming language. And what does that even mean? So this means we'll be dealing with a lot of memory and is based around performance. So Rust is very, very fast. Just put that out there. So a language similar to this is C++, which is also a systems-level programming language. But unlike C++, Rust is far more secure. So we'll go over that in a later video though. But Rust is also super fast for many reasons, but primarily due to the fact that the language does not have a garbage collector. So in a language like JavaScript, for instance, you have a garbage collector. So in JavaScript, you can declare a variable. You don't have to keep track of that variable. You can send it wherever and whenever it needs to be. But with that comes some issues, mostly performance-based issues. It becomes a lot slower because everywhere you send it, you gotta clean up after it. But with Rust, that problem is gone. So whenever you send in a variable, you have to send in a reference to that variable. With Rust not having garbage collector, you have to take care of memory management on your own. So this is kind of a caveat to the language. So there's always some kind of trade-off. It's going to be faster, but you're going to have to keep track of certain things. But there are certain elements of this programming language that give you a little assistance with that, like ownership. And Rust is also super versatile. So you can make CLI apps, web servers. You can use it for web dev, which I actually do professionally. You can program a Raspberry Pi with it, and you can do all sorts of things. But without further ado, let's go and take a look at some Rust. So the first thing we're going to look at is actually variables. So there's two different ways to do variables in Rust. So it's going to be, or sorry, technically three. So you have immutable, mutable, and constant variables. So first we'll take a look at immutable variables. What does immutable even mean? So immutable means it cannot change. So if you declare a variable, that variable is not going to change. So you can guarantee that throughout your program, it's not going to change. So I'll show you an example. So we'll say if I can spell immutable. Alright, so to declare a variable, we'll say let, similar to JavaScript, if you've programmed in JavaScript. So we'll say let, we'll say my var equals 12. So this is an example of an immutable variable. So throughout this entire runtime of the program, that my var will never change. It's basically a constant. Except there is a different constant, which we'll also get into. So if we want to, say, change it, we can try to. We'll say equals 13. We'll print it. My var. Alright, let's save it. Aha, we get an error here. Cannot assign twice to immutable variable my var. So that means you can't change it. So there's proof right there. If you take it away, we're good. Open up the terminal, and if we cargo run, there you go, we get our 12. So that's an immutable variable. We'll just close this out. But let's look at a mutable variable, otherwise a changeable variable. Alright, so how do we declare a mutable variable? So same way, we'll say let my mute var equals, we'll say 13. So right now this is immutable. We can't change this. So in order to change it, we need to add the mute keyword. Now it is changeable. So if we say mute, there we go, mute var equals 14, if we save that, we'll see no error. We see this yellow squiggly, just meaning we haven't used this variable yet. So if we just go here, we'll print it out, just so we can see my mute var, save, open the terminal again, cargo, run. There we go, 14. We successfully changed it. So that's the difference between immutable and mutable. All right, so let's go and take a look at constants. So constants. So a constant variable is going to be initialized with all caps, and we'll use the const keyword. So what we'll do is we'll say const, the keyword const. We'll say my underscore const. Now it is best practice when you're making a constant variable to put it in all caps. And we'll say 15. And we will specify that this is an I32. This is the integer type, meaning it's an unsigned 32-bit integer. Sorry, no, signed. This is a sign, so I means signed, which we'll also go over. So it's I. And if we print this out, print line, my const, save, we'll run, and we'll just do here. And there we go, 15. All right. So with const, if you declare a variable with const, you cannot add a mute keyword and you cannot change it. So it is ultimately constant. It will not change. See, if I try to add the mute keyword here, it's not gonna let me. See, error. So a constant will never ever change. All right. So now we looked at how to make variables. Let's look at some data types. All right. So with data types, we're going to focus on scalar types for right now. We're not going to focus on strings, because strings are a huge thing in Rust, which we'll see eventually. But for scalar types, they represent a single value. So these single values, mainly we'll be focusing on integers, floats, Booleans, and characters. And so first we'll take a look at integers. So let's see. All right. So an integer is a whole number. So 1, a million, 3, 75, whole numbers. They can be signed or unsigned. So like I was talking about earlier, up here with this I here, that means it's a signed integer. So it can be negative or positive. Unsigned will always be positive. You don't have to worry about it being negative. So we have, so with integers we have multiple different lengths. So you can specify the length of an integer by using 8, 16, 32, 64, or 128 bits. So by default, you don't have to specify this. Default, it will be an I32-bit integer. And you can specify if it's signed or unsigned. And to declare an integer, all we'll do is say let my int equal 2. There you go. As you can see, by default it is at I32. Now we can specify by doing, let's say my unsigned int equals, well sorry, no, take away the equals, we'll do colon u32 equals 6. So if you want to do an unsigned integer and you want to specify that, that's how you would do that. All right. And if you want to do, let's say you have a negative number, we'll say my neg, we'll say negative int equals -9. There you go. So there you go. That's how you would do a negative number. Alright. So now that we got integers out of the way, let's look at floats. Floats. Alright. Paste that in. Alright, so floats. Floats are basically just decimal point numbers. If there's a decimal in it, it's a float. And they come in two lengths, F32 or F64. So 32-bit or 64-bit. And again, you don't have to specify the length right away. The default will be F64. Now, it's going to be just as fast as F32, but it's going to be more precise. Alright, so how do we declare this float? How do we initialize a variable? So we'll say let my float equal 5.0. There you go. As you can see, our default is our F64. Perfect. That's all you have to do for a float. Alright. Let's talk about Booleans. Alright, so from other programming languages, you might find this familiar, but a Boolean is just going to be true or false. You can initialize using the bool keyword or without, and mainly Booleans are used for conditional statements, which we will also go over in a later video. So we'll say let my bool equal false. As you can see, defaulted to bool. But we can also do let true var, we'll specify it to be a Boolean, equal to true. Either way you want to do it will work just fine. Alright, so now let's take a look at characters, our last bit for data types here. Characters, let's see. Alright, so a character or a char is just a single character using single quotes. So the letter A, number 1, an emoji, some random font, a symbol is a character, and we will initialize like this. So let my char equal, as you can see here, once we get that single quote started, it knows it's a char. So you initialize it with the single quote, not double quotes. You'll think it's a string. Single quotes. So we'll say char is, I don't know, B. There we go. So we have a char that's equal to B. We can also do numbers and emojis. So char of 1 and a char with an emoji face is also a char. Alright, so that's data types out of the way. Let's take a look at how we store some of this data. We have a tuple to start off with. So a tuple is just a way to store a list or a group of different values. So they don't all have to be the same data type. They can be actually a mix of data types. You can have Booleans, characters, integers, just a mix of different data types. And then once you declare a tuple, it cannot shrink or grow in size. It's a fixed size. So you can't, so like an immutable variable, you can't change it. You can't remove stuff or take stuff away. It's like that for the duration of the program. Alright, so how do we declare a tuple? We'll say let my tuple equal, so we're going to put in parentheses here. We'll put in a char. We'll put in a number. And we'll put in a Boolean. We'll put in false. These are all valid. As you can see, it'll take in all these values here. You know, specify which ones they are. Let's throw in a number. Let's see it. Boom, I32. It checks our number. All right, so how do we access things in our list here? So what we'll do, we'll make a new variable. We'll say let's, we'll grab our char. So we'll say my char equals, we'll say my tuple, and we'll use the dot operator. And a tuple is 0 index, meaning that our A is actually place 0. So it doesn't start from 1 to whatever, it starts from 0. So to get our A, we're going to want our index of 0. So we'll put 0 there. And yeah, we can see it, so we'll print line. So we'll say this is our char at index 0. And we'll throw in my char. Actually, we might get an error. Don't we actually have? Oh no, we don't. I put me char. Okay. All right, let's test it out. So save it, run it. There we go. We got our A. Perfect. That's just what we wanted. So that's how you declare a tuple, and that's how we access different indexes in a tuple. Similar to a tuple, but you can only store one type of data. So you can only store a list of strings, or you can only store a list of integers. It has to be the same data type. It cannot mix and match like a tuple. So you would use an array when you have a list of items you know will not change, or you know will not likely need to be added or removed. So like a tuple, an array is fixed. So this means, again, you can't change it during the duration of the program. It has to stay the same. So you cannot remove or add objects. So not objects, data to it. So for example, if you were using an array, you'd probably use it for something like days of the week, months. You know these will never change. There's always going to be Monday through Sunday. There's always going to be January through December. So that's what you would use an array for. All right, how do we declare an array? So we'll say let's my array equal, we'll do an array of chars. So A, B, C, let me do all 26 real fast, give me a second. I'm just kidding. That's ridiculous. All right, so we have A, B, C, our list of chars. All right, so how do we access, I don't know, let's access B. So to do that, we'll say let get B equal, and we'll say my array. We'll use our brackets here, and we'll give it the index of B. So again, it's 0 indexed, so A is going to be 0, B is going to be 1. So if we want B, we'll put in 1. As you can see, it identifies this as a char, which is good. That's what we want. We'll just double check to make sure we get B. So we'll say print line, this should be B, and we'll put in get B. Save it. We'll run it. Here we go. Should be B, and we got B. So perfect. So thank you guys for watching. I will see you guys in the next video with some more Rust.